Welcome. The Passive Sampling Update team is proud to present an overview of the Sentinel passive samplers. This quick video will provide a high-level overview of the device, as well as instructions on how to use, deploy, and retrieve the device. For more information on this and other passive sampling technologies, please visit the Passive Sampling Technology Update Guidance document. The Sentinel passive sampler is a time-integrative accumulation type sampler specifically designed to measure PFAS in aqueous media. The sampler is a small tag-shaped device made of high-density polyethylene or stainless steel. The sampler is applicable for use in multiple types of aqueous media including groundwater, surface water, and sediment pore water. Let's look at how the device is constructed. There is a small absorbent resin in the center of the housing. The resin consists of a modified organosilica sorbent infused with polyethyleneamine and copper ions to optimize PFAS sorption across a range of carbon chain lengths. The resin comes pre-wetted with glycerol from the manufacturer, which allows the samplers to be placed directly into the sampling medium without pre-treatment steps. The polyethylene housing can be deployed to groundwater or surface water, and the stainless steel housing can be deployed to sediment to sample pore water. While the sampler is deployed, PFAS compounds in the sampling medium accumulate into the sorbent material. Sampling rates are determined for each PFAS chemical in the user-defined analytical method. These rates are dependent on flow rates and temperature, and those parameters must be collected and recorded during both deployment and retrieval. The field data supplied is incorporated into the laboratory calculation of the PFAS concentration. The deployment time of the sampler is typically 10 to 45 days. The sampler is shipped inside a 50 ml centrifuge tube and must be kept in a clean sealable bag for shipping the sampler to the laboratory after retrieval. Because of the sampler's small size, a variety of attachment methods can be made depending on the aqueous environment being sampled. It is important to make sure the sampler remains fully submerged in the aqueous environment. A steel weight can be added to the device to ensure the device stays submerged. For use in monitoring PFAS in unfiltered private domestic wells, the Sentinel sampler can be deployed to a toilet tank to easily monitor concentrations found in these wells. At retrieval, detach the sampler from its deployment point. If the passive sampler housing or weight contains gross sediment, shake off manually and gently rinse the sampler and weight with PFAS-free deionized water. Return the passive sampler and weight to the retained centrifuge tube the sampler was shipped in. Pack the retrieved samplers on ice for shipment to the laboratory. The field team must record the date and time of deployment and retrieval, water temperature, and flow category, groundwater, surface water sediment, on the chain of custody form to permit calculation of PFAS concentrations. Some advantages of the Sentinel device include: the small construction of the sampler makes it easily deployable in virtually all aqueous media. The single-use nature of the device limits the possibility of cross-contamination. Since the sorbent material is time-integrated, the sampler is ideal for capturing media spikes in concentration and for low concentrations. A few limitations include: the sorbent material must remain submerged during deployment, and the sampler must be shipped to certified laboratories to analyze the technology. The limited availability of experimentally derived sampling rates may not be available for all PFAS chemicals of interest. For more information on the Sentinel passive samplers and other passive sampling technologies, check out the ITRC Passive Sampling Update web guidance.